Hello everyone, welcome to the course Climate Change and Extreme Events. In the last lecture we had discussed about what we have covered so far in week 2. Then we have also discussed two assignments based on hydrological extreme events which we have the historical data was already available. So, we will go through the first part of our assignment where we are looking at which area in the or different region of Indian territory is basically highly flood affected. So, this will be we will do using the district wise approach, where we will work on individually which area has the highest maximum flood inundation area reported since let us say 1901 to recent 2023-24 like that. Then what we will do, we will use that area, the vulnerable area in the flood part, the district, and then we will look into what is the overall, how it has behaved throughout the time, a temporal analysis of that particular area as well. Then the second part of this assignment, we will basically look into the similar type of the problem, but other hydrological extreme, which is called drought conditions across the whole Indian region, and then we will look which region or which district of India is significantly affected by drought activities in the recent or historical period like that. So, this is the website which I have suggested in the last lecture, where it is a kind of a India flood atlas developed by IIT Gandhinagar. So, here what we can do, we can there are several tabs here, for example, N1 maximum flood, historical maximum flood, flood risk and all that. So, what we can do here, we can first look what is the historical maximum flood occurrence area in the Indian region. So, when I click this tab, it will be open this particular page where you will see different Indian region with the city name as well, and some some marking with lines and all. Here in this tab, the left part of this particular web portal, we have to select either state wise or the district wise. So, suppose we start with the state wise, which state has the highest maximum flood occurrences in the past years. So, we will select the year, and then we will select multiple, you will get the idea about, let us say this is showing that historical maximum flooded area across different Indian states. So, if you look at those states which are parallel to the Himalayan region, for example, Punjab, Haryana, Delhi, Uttar Pradesh, Uttarakhand, Bihar, and then some part of West Bengal and then Assam, all are these areas are showing a very high historical maximum flooded area. What is exactly a maximum flooded area? It means that how much area of these regions are covered with flooded part, maximum amount of flood if it has occurred in the historical time period like that. So, if you look at here, suppose this is your Punjab region. So, if I click here, you will see that the total percentage of historical maximum flooded area is around 16.72%, which is around 9,782 kilometer square. When you further go down in Haryana, we see that the total maximum flooded area is around 7,674.69 kilometer square, which is roughly around 15% of the Haryana region. If you go to let us say Uttar Pradesh, here you see that the area increases significantly, which is around 34,570, that is close to 12.69%. And when you hear state of Bihar, here it is around 25,938 kilometer square and like that. So, when you have higher larger region, although the percentage wise it is less, but the magnitude is very high, which means if you look at the Uttar Pradesh region, here the flood area affected by maximum flooded region like that has the highest or relatively highest value compared to all these different regions like that. So, suppose if I click let us say here Uttar Pradesh, which is showing the highest magnitude of flooded area. So, if I select it here, you can see different you can now closely see that the neighboring regions with their colors as well. Now, if I go to the annual maximum, so this is the this is the tab which generally shows that what is the maximum amount of floods or flooded area was reported in these different regions like that. Now, if I am interested in, let us say, look at what is the annual fluctuation of these flooded area across different region, whether it is increasing or decreasing, it is kind of a proxy which tells about how much area of that region is affected by, let us say, increasing amount of historical flood events, or let us say is more or less stable, or it is not like very high flooded area like that. So, if you go to this particular tab, annual maximum flood area, and then you can again select, let us say, the here state wise, and now you select here, let us say, a particular year, let us say latest year is 2000, let us say 20, you select, and then here you state, let us say this is Uttar Pradesh. So, now this is the map of Uttar Pradesh, which is showing that around 8.55% of area was affected. In the when we talked about maximum flood area, it was around 13 or 14% like that. Now, you can also look at what is the time series of the flooding area which has been changed across this particular region. So, if you click here show time series data, so basically you can see that this data tells you about how the flooded area was fluctuating across different years since 1901 to 2020 like that. So, here if you see that this is the year when you when we have a highest flooded area in Uttar Pradesh, which is around 34,570 kilometer square. And if you look at in the historical period, primarily if you look at more recent period, what we observed that the flooded area has been significantly reduced compared to the historical past. What could be the reason behind it? So, it could be because let us say we have already engineered our rivers system, we have also made several dams and all, that could potentially decrease the chances of flooding in the downstream region. It is also possible that rainfall climate has also significant role to play when compared to, but when we look at, let us say, the newspaper article or let us say several different media reports which suggest that floodings has been increased in several parts of Uttar Pradesh, particularly Tarai region. Why it is happening? So, it is possible that the flooded area has been decreased, but those area which are likely to be flooded are directly occupied by, let us say, growing populations or those people who are now living very close to the river system, and therefore, we observed a very huge flood related risk in those regions. So, if you recall in the drought or in the floods analysis, we have already discussed that there is a hazard, there is exposure, there is a vulnerability, and there is a risk. So, hazard is basically when we have frequent flooding events which are continuously increasing and flooded area is also increasing like that. So, that is hazard. But when you talk about exposure and vulnerability, it is a function of what kind of the construction we are making it, or let us say how many peoples are living close to the river channel and those regions which are likely to be flooded. Therefore, the flood vulnerability might have been increased because of the human activities, we are altering the river system or changing the land use land cover system like that. But in historical perspective, it is observed that this you know the floods vulnerability has been significantly reduced like that. Floods, not exactly flood vulnerabilities, but the flooded area has been significantly reduced in the Uttar Pradesh. Let us talk about some more reason where we can see what is happening. So, let us little bit zoom it out, and then you can see that let us say in 2020 we have several other regions which is also highest highly affected by flood areas. For example, if you look at Bihar, Bihar is the one region where most of the rivers, Himalayan rivers, annually creates significant damage because of the flood events. So, if you go to here, state Bihar, let us say I am changing this data to Bihar, and then I am saying show the time series. Now, you can see here in the Bihar, if you look at let us say a data set since 1901 to 2021. So, it suggests that the data has been significantly reduced, the magnitude has been significantly reduced compared to historical period. So, the data suggests that the flooded area has been significantly reduced. However, if you report the news or other articles or research papers and all these suggest that the flooding vulnerabilities or risk has been significantly increased in the Bihar region like that. Now, little bit go into deeper into which area, let us say I am interested in which area in the Bihar is significantly affected by the flooding. Is there the the area which are close to the Himalayan region or Nepal region, or the area which is South Bihar region like that. So, what we can do here, we can click it district wise analysis, and then let us say I select here again 2020 map, which basically shows the 2020 layer map of one particular region, and let us say here you can see that. Now, this is the region where the Bihar is located, and it is now several districts are affected by flooding events. So, those districts, it appears that which are in the middle of the Bihar is all are highly susceptible to the flooding events. Why is it so? Because we know that Ganga is flowing like this, and there are several rivers which are meeting into the Ganga river and making Ganga river channel much wider, and therefore, it has more potential to flood in the neighboring region. Potentially, this is the region where the Kosi river and other rivers meets, and that creates a significant high amount of flooding areas that creates a significant problems there. So, for example, if I zoom here, let us say this particular region, let us say Patna and Begusarai and Khagaria and all these region. So, let us say if I talk Khagaria region. So, if I click it here, so I can select this particular district from here. So, I select Bihar district, and then I select Khagaria district, which is KHS. So, now this is the district boundary of Khagaria in Bihar, which is the one of the region which is highly vulnerable in terms of flooding area. Now, I can click it here, the show time series option. Okay. So, now it shows that although in the historical period, let us say in 1990 14, 1990 38, 1990 25, these the area where the district was highly flooded areas compared to the recent one. Let us say if you talk about the recent flooding anomalies or areas, like in 2011 it was around 982 kilometer square, and it has 1000. So, it was like more than 20% or 30% higher area was affected compared to the recent maximum amounts like that. Although if you talk about these regions, these are flood risk, flood vulnerable region, possibly because of the change of the land use practices in these regions like that. Therefore, it affects most of the people, or because of the highly increasing number of population or peoples living in those regions also can be affected by the flooding events in these regions like that. So, this is the one way of we can analyze the flooded areas, which is a proxy of flood potential, flood risk of those regions. You can also overlap these data set with different types of other data set. For example, what is the land use land cover in those region, what is the population density of that region. That can give us more sense about what is exactly the flood risk of that regions also. So, you can do that analysis, and then you can compare 2, 3, 4 districts in Indian region, and then you can compare how the flooding or flooded events, flooded areas has been increased in the past or not, like that. In the second part of the assignment, we talked about we have to look at other types of hydrological extremes, that is called drought. So, drought is basically when we do not have sufficient amount of rainfall for very prolonged period of time, and therefore, it creates some sort of water shortage or water scarcity in those regions. So, in this assignment, I have also referred one particular link, which is indiadroughtmonitor.in link, where you can go to this particular link and you can analyze which of those regions are highly susceptible to the drought events across Indian regions like that. So, this is the one map which shows that what is the which area has been significantly affected by drought events. For example, again the same region you look at where different clusters also appear here, which are close to those Himalayan river system or Himalayan river basins like that, are significantly affected by your drought anomalies, which means that these are the region which is also receiving highly irregular rainfall, and therefore, the drought pattern is also very common here. For example, if you talk about some part of Uttar Pradesh, Bihar, let us say northeast region, Arunachal Pradesh and all, and also the Himalayan part, for example, Himachal Pradesh, Leh and Ladakh, and some part of Jammu and Kashmir. These are the areas where we have seen that significant exceptional category of drought events. So, when it is showing the negative numbers, it shows that the drought is very severe, and therefore, in these regions the drought events can affect significantly to the neighboring districts like that. So, this is now if you can look at, let us say drought early warning, not drought time series data set. Let us see. Okay, it is not working, but yes, we can look at this particular data, and then we can identify those regions where the significant drought is affected, or those regions where the drought events are more frequent or highly exceptional category of drought, or extreme or severe category of drought in those regions, and highly affected by frequent drought events like that. So, this data set of drought is largely created by standardized precipitation index or standardized precipitation evaporation index. So, SPI and SPEI, which we will talk about this index in the later of the classes, where how to use these indexes to find out the drought events, or to classify several different types of drought events across India like that. I hope this assignments help you out to understand what is exactly hydrological extremes and how we can classify them, or how we can assess their severity across Indian region, and then we can also compare different parts of the Indian district or state based on their flood or drought susceptibility. Thank you so much.